All right, back for part two here. Before I go on to method three, which I'm sure all of you will like just the most, I want to mention that once we found the x-intercept, or we're happy maybe that we found the x-intercept, and we'll see in a second that 0.645 isn't the x-intercept, but it's reasonably close. We should have known that it was closer to 0.64 than 0.645, just because there's another zero in there. It's actually a lot closer to 0.64. But let's say we went with that. If the x-intercept is equal to that, then we'd actually have to say the solution would be, the solution is, and we state the solution. Maybe I'll do it in set notation this time. X is greater than 0.645. Even though in saying that, I know there's a solution in there, probably 0.644, that wouldn't be in my set because I've rounded. I want to just mention that even though we found the x-intercept, or thought we found the x-intercept, that we got to actually go ahead and state the solution still too. Method three, I think method three will probably be everyone's favorite method, but not always accessible. Method three is kind of a combination of these two things, but we're going to use technology. This is the sort of thing we did when we couldn't factor something using the factor theorem, or bad things were happening. We were asked to find a minimum or a maximum. We don't know how to do that yet. We turn to technology. So warm up the old graphing calculator, press y equals, well, once I turn the darn thing on, okay, and there's all my log stuff from before. I got some crud in there. I'm going to clear it all out, clear out the crud. And one little mystery is, how do I graph a log function? Well, it's the change of base, and I think we talked about this before. If I want to do log base 2, remember this is the log of the top divided by the log of the base, and then I'm adding x. There's my function. And hopefully the window settings are, I'm going to just go zoom, maybe zoom standard, to see if I'm, yeah, there's my solution right there. I could zoom in, I suppose, and my graph wasn't so bad, eh? Wasn't so bad. That green graph kind of looks like my graph there. But how do we actually use the calculator to find this? Remember, there's a menu. Second calc is a nice menu. I can find the zero. Notice that if I'd rather find where graphs intersected, or a minimum or a maximum, I could do all that stuff. But I want to find a zero here. Zero, and I go a little bit to the left. Right, there's the spider, a little bit to the left. Right bound, a little bit to the right. And actually, the reason why it's a combination of our first two is the calculator uses kind of like a guess and improve strategy. It's a pretty fancy guess and improve strategy to find this root. This is still just an estimate. This is still just the calculator has used some sort of program, a numerical method, to get it zero. I'm going to copy this just so I don't have to remember all those digits. Where'd my, oh, that right there. Edit, paste. Oops, no, not spelling. Close. Edit, paste. I'm going to grab that and put that down there. The x-intercept. The x-intercept was x equals 0.6418574, so on, dot, dot, dot. There's more decimals. But then we say the solution is, and I'm going to use interval notation just because for funsies, 118 in infinity. Dandy. And this is using TI-83, what was it, the zero feature, zero function. Maybe your favorite technique will be this one. I don't know. The good old Desmos. What's nice about Desmos is it'll actually put in a base for a log function for you. How do I get base 2? I could either click on the little subscript here, or on my keyboard, because I'm using the keyboard. I don't know if your phone has this. Your phone, if you're doing it on your phone, you'll have to use that button, and that's all good. But I got my keyboard, and I can just use the underscore, and you see how it kind of shifted into the bottom there. I'm going to put in base 2, go to the left so I'm out of the base, and then I'm going to put in X. There's log base 2 of X, and then I'm going to add X, and what's awesome, look at that. There's my root. There's my x-intercept. Again, not exact. Desmos has used some sort of guess and check algorithm as well. It cannot solve this exactly. This is just some sort of numerical algorithm that's put into the computer to get 0.641. Okay, so I'm going to go back to the note here and say or use Desmos in a similar way to find x-intercept. Notice that you have to sort of acknowledge that you've used technology when you use this solution. Otherwise, you're just copying out of the back of the book, right? All right, homework time. Except I want to mention something. I want to give you a little helper hand. For each graph, this is the first one. For each graph shown below, state the solution to f at x equals g at x. And we don't know what these equations are. Kind of looks like maybe a trig function with a linear function, right? So where are the graphs equal? Where are the graphs equal? Well, that's where this x value right here, and right here. So I'd say the solution set for AI here is, well, what's the x value? It looks like maybe around 1/2, and 2, and 3.5. Notice there's two ways. If I actually had these equations, I could have put g onto the other side and then solved and found where the combined function is 0, or I could put these both into technology and look for the intercepts, right? I just click on the intercepts, or use the calc menu intersect feature, right? Two ways to do that. So for B, and I'm not going to do all these, doesn't matter all of them. Here I'm looking, where is f at x greater than g at x? So for what values of x is the curvy function greater? Where is it above? Well, if I just sort of shaded in the ones where it was greater, well, I'd say here, not in here, but then again here, right? That's where the curvy function is above the linear function. And if these continue, this one's going to keep going up this way. This one will go back and forth. It'll never be greater than it again. But how would I describe those? And notice that I'm not interested in the y values, only the x values. So I would say from here to here, I've got the solution set 0.5 is less than, and just less than because there's no equal to here, less than x, which is less than 2. And I put that together, that's set union, with another set. How would I describe those? About 3.5 and over. X is greater than 3.5. And of course, you could write those in your interval notation, whichever style makes you happier. All right, that's it. Good luck solving your unsolvable equations. We'll talk to you soon. Bye-bye.